If you have a Docker file that's taking too long to build, this video's for you. Hi, I'm Peter, and today I want to help you make your Docker builds faster. As you probably know, Docker has a built-in mechanism that tries to cache as much of your build as possible, but it comes with a caveat. The way you write your Docker file has a big effect on how much time cache can actually save you. I'll show you how to rewrite this Docker file to maximize cache usage and drastically reduce its build time. But using cache efficiently starts with understanding how Docker caching works. If I build this example twice in a row, unsurprisingly, the second run is entirely cached, which the build output confirms. The main rule is that if you edit an instruction, the outcome of that instruction and every instruction below it may change. That part of the Docker file will be rebuilt, no cache. The output confirms this. Line 3 is still cached, the rest got rebuilt. By consequence, an apt update followed by an apt install does not necessarily rebuild if newer package versions are available. Different users of the same Docker file may get different versions of the same system package depending on how old their cache is. If you want to make sure that everyone with the same Docker file runs the same package versions, you can always specify version numbers explicitly. For the add and copy instructions, an extra rule applies. If you don't change your Docker file at all, but you add, edit, or delete any of the files that are copied, then cache cannot be used and the rest of your image will build without it. For from instructions, keep in mind that if you download a new version of your base image, your Docker file will not be able to use cache next time you build. By default, Docker build will not check with Docker Hub if your base image is still up to date, so cache impact should be limited. And that's a quick summary of the caching rules. You can read the official explanation on the Docker website, link in the description. With these rules in mind, it's time to do some optimizing. My unoptimized build took roughly 95 seconds. Most of that came from installing the necessary packages for Python and pip. Luckily, I don't have to do any of that. On Docker Hub, you'll find an official base image for Python that already has both commands pre-installed. I'll change my base image and remove the Python packages from the apt install command. Look at how much time we saved, that's huge. A 9-second build is great, but to be fair, this is an artificial example with a tiny list of dependencies. Most projects need a bit more help, so we're gonna keep going. The apt install command doesn't depend on my project files. By moving it all the way up, Docker won't have to re-download my system dependencies every time a project file changes. Optimization number 3. At the start of every Docker build, the Docker client packages the directory of your Docker file into an archive and sends that to the Docker server for processing. But not everything in your Docker file directory is relevant to the build. That Ven folder over there has a size of 26 megabytes. Now granted, it's nowhere near as big as a node modules folder, but I'm gonna exclude it anyway. I'll create a Docker ignore file, which is similar to a git ignore file, and add the Ven folder to it. The Docker ignore file will also ensure that the folder is excluded from my copy ..dot command. This has two consequences. One, a change to my Ven folder will no longer cause the cache to be regenerated. And two, my resulting Docker image will shrink by about 26 megabytes. Double win! But I still have a big problem. Every time I edit my Python files, the pip install instruction loses its cache. Fortunately, I can easily fix this by copying in requirements.txt before I copy in my Python files. Despite the optimizations, there will still be times where I'll have to edit my requirements.txt file. And that will require cache to be regenerated. There's just no way around that. But man, waiting for Docker to re-download Python dependencies because the cache was no longer valid is kind of frustrating. Wait a minute though. Pip keeps downloaded packages somewhere in your home directory. If you could just remount this directory while the cache is being regenerated, you could avoid re-downloads. Well, good news, you can. Here's the syntax. This will work for pip, but also any other package manager that stores downloaded packages in a folder. For apt, this isn't always the case unless you do some extra configuration. Since changes to my code only affect line 8 and below, caching the pip downloads is good enough for me. Be aware though that this mount cache will be shared with other Docker builds that mount the same target path. While that can be useful, you'll have to be careful if you run two Docker builds at the same time. You do get a few options to configure the cache behavior, so I suggest you check out their documentation for more details. To recap my advice, use a specialized base image, install system dependencies as early as possible, list anything that's irrelevant to your Docker build in the Docker ignore file, install application dependencies before you copy in your code, and if your dependency downloads take a long time, consider caching the download folder. Here's another DevOps video you might find interesting, but before you go, I'd like to know what you like the most about Docker and what you find the most frustrating about it. Maybe I'll tackle it in a future video, who knows? Thanks for watching, see you next time.